Okay, lesson 103 today. The title of lesson 103 is volume, and that is found on page 671 in your books. The three objectives that we'll cover are: find the volume of a rectangular solid. We've done that a little bit. Remember that rectangular solids are just those three-dimensional objects, and when we label rectangular solids, it's cubed instead of squared. Okay. It also says choose the appropriate formula to solve a problem. Remember, we have formulas for area. The formula for volume is now length times width times depth. So you'll do the, I guess we'll talk about that a little bit later. But the formula for volume is length times width times depth. We'll also choose the appropriate unit of measure for a given situation, and that's everything from, if you're measuring from here to Dickinson, would you measure that in miles? Probably. Would you measure it in feet? No, you'd have too many feet. It just wouldn't make sense. It wouldn't be very simple. And I guess if you measure your desk, would you measure that in miles? No, you'd measure that in something smaller, maybe centimeters, maybe inches, maybe feet, something like that. Okay, now the new concept on page 671. It says the volume of an object is the amount of space the object occupies. Geometric figures that occupy space include cubes, spheres, cones, cylinders, pyramids, and combinations of these shapes. In this lesson, we will concentrate on finding the volume of rectangular solids. The units we use to measure volume are cubic units. Here we illustrate the three types of units we use to measure distance, area, and volume. Okay? So I'm going to I drew this line on the board. That, let's say, represents 1 centimeter. Now it's obviously bigger than 1 centimeter, but this is just used to represent that 1 centimeter. Now area, remember, is a two-dimensional object, but it can fill space. The length, that might be the length of this wall. We could measure from one side of the wall to the other, and we could figure out the length of the wall. If we wanted to figure out how much carpet we wanted to put in this wall, we'd have to measure the area. We'd take the length of one wall times the width of the other wall, and we would multiply those together to get a unit of measurement squared. Okay? When you have centimeters squared, that's, again, it occupies area. Now, if we had cubic units, that is, okay, that actually occupies space. That would be the air in this room. We would take the length times the room times the width of the room, and then we multiply it by the height of the room, and we would find out the volume, or the amount of space that occupies this room. Example number 1. It says, give an example of a unit that might be used to measure. Example 1. Okay, the first one says the amount of molding around a room. Okay, the amount of molding around a room, that is, I guess, the baseboard in houses, the stuff around the bottom of the room that connects the floor to the wall, kind of. Okay, so if we needed to find the perimeter of the room, or the amount of baseboard or molding around a room, we would find the perimeter of a room. If we wanted to find the perimeter of the room using, I guess, the United States system, what unit would we use? Would we use inches, feet, or miles? Okay, it's pretty obvious that this is quite a bit less than a mile, and it's pretty obvious that if we did it in inches, we'd have very many inches. But if we did it in feet, that would be the most accurate measurement that we could use. Okay, for B, it says the amount of carpet on the floor of the room. Okay, the amount of carpet on the floor of the room. Now, would we measure a straight line? No, we'd have to not only take the length of the room, but the width of the room and multiply it together. We would need square feet to find the amount of carpet in a room, or we'd need feet squared. And that's your answer for B, part B of example 1. Part C of example 1, it says the maximum storage capacity of a room. That would obviously be everything that you can fit into that room. You'd need your volume for that. Okay, and we know that volume now is feet cubed or cubic feet. Okay, so these are your answers for example number 1. There are 3 of them. The molding or the distance around a room, you'd use feet. The carpet or the amount of area that a room has on the floor would be feet squared or square feet. And then if you wanted to find out, I guess, the maximum capacity or everything you could fit into this room, you would do feet cubed or cubic feet. Okay, example 2. We will turn our sheets over. Or I guess I have a little something to read first. It says to find the volume of an object, we calculate the number of cubic units of space the object occupies. It says how many 1-inch cubes are needed to build the 2-inch by 2-inch cube. So I'm going to draw the best darn cube that I can. Okay, and it says that each side is 2 inches. Okay, so I know that it's 2 inches wide, that's my length. I know that it's 2 inches tall, that's my width or my height. And I know that it's 2 inches deep, so my depth is 2 inches. The formula for volume, remember, is length times width times depth. So I'm going to multiply these numbers. Okay, length times width times depth. Okay, I know that 2 times 2 is 4. 4 times 2 is 8. My answer is 8 cubic inches or 8 inches cubed. Either answer is acceptable, as either label is acceptable. But how many 1-inch cubes would we need? Well, it would be split up into 2 deep, it would be 2 tall, and it would also be 2 wide. Now there are a lot of lines going on here, but if you wanted to count them all, you'd have 1, 2, 3, 4, and then 5, 6, 7, and this back one here would be the 8th. Okay, there are 8 cubic inches or 8 inches cubed. But that wasn't an example problem, so you don't have to write that one down. Okay, example number 2. It says find the volume of this rectangular solid found on page 672. It's it's 2 centimeters wide, it's 3 centimeters deep, and it's 2 centimeters tall. Okay, length times width times depth. Length times height times depth. It doesn't really matter. You just need to multiply the face, which is 2 times 2, and then multiply that by its depth. So we have 2 times 3 times 2 to find our volume, and this is for example 2. And we know that 2 times 2 is 4, 4 times 3 is 12. Our answer is 12 centimeters cubed. 12 centimeters cubed for example number 2. It says, why is the answer labeled cubic centimeters and not square centimeters? Well, volume is measured in cubic units. Area is measured in square units. Okay, example number 3. What is the volume of this solid? It gives us another rectangular solid. And again, the front face, it shows 2 inches, and it's 3 inches tall. And it looks like it is 4 inches deep. Alright, so we need to make sure that we multiply length times width, 2 times 3, times the depth of 4 inches. We take 2 times 3 times 4. 2 times 3 is 12. 12 times 4 is 48. 4 times 2 is 8. 4 times 1 is 4. Okay, my answer is 48. What's my label? Oh, I'm sorry, what did I do wrong? Shoot, I'm sorry. My multiplication was incorrect there. 2 times 3 is not 12. 2 times 3 is 6. 6 times 4 is 24. Alright, so your answer is 24, but we still have to label it, making sure that when we have volume, our label is 24 inches cubed, or again, also an acceptable answer, or an acceptable label would be 24 cubic inches. They're the same thing. Okay, on the bottom of page 672 it says, notice that the examples 2 and 3, we found the number of cubes on the bottom layer and then multiplied that number by the number of layers, which is the height of the solid. And then they just go on to show you that the formula for volume is length times width times height. This was your answer for example 3 too, by the way. Okay, so on the back side of your sheets, I'd like you to write this down. Volume equals length times width times height. Write that formula down on the back of your sheets, please. Alright, so let's do example 4. Oh, there are 6 examples today. Example 4, it says, Emma keeps the quilt she makes in a sturdy cardboard box. She plans to cover the top of the box with fabric. Choose a formula to use and use it to decide how much fabric she needs. Alright, so she has a box. Again, sorry if my box isn't very good. Oh boy. Okay, that'll work. It shows that it's 36 inches wide. It shows that it's 24 inches tall, but I mean any one of these is 24 inches. So I'm going to use this one. It's 24 inches tall and it's 24 inches deep. Length, width, and depth. Now it says she plans on covering the top of this object with fabric. How do we figure out how much fabric she needs for that top? Well, we have to figure out what the area of the top is, right? It's just like putting carpet on the floor, except in this situation we're putting fabric on the top of this. So we need to find the area of the top one for example 4. I guess, and that's only example 4, part A. How do we find the area of that? Well, we take the length times the width of this face, of this top face. We know that the length is 36 inches, and we know that the width is 24 inches. So if we take 36 inches and multiply it by 24 inches, we will find out that 4 times 6 is 24, 3 times 4 is 12, plus 2 is 14, 2 times 6 is 12, 2 times 3 is 6, plus 1 is 7. After we add that up, we find that we need 864 inches squared of fabric for part A. And that's only part A of example 4. Okay, now let's look at part B of example 4. Part B says, how much space is inside the box? Choose a formula and use it to determine the volume of a box. Okay, we know that the formula that we need right now is the volume formula. The formula for volume, again, is length times width times depth. Okay, length times width times depth. So we need to multiply these 3 together to figure out our volume. All right, so first I'm going to use what I've used already. We know that length times width times depth. We multiply length times depth times width. We multiply length times width times depth. It doesn't matter which order you do that in, or which order you multiply those numbers in. Now we've already done 36 and 24, 36 and 24. So we've already taken care of the length and the depth. Now we need to multiply that answer by the width of 24. So I'm going to take 864, my length times depth, and multiply that now by the height of my object, or the width. And that'll give me my volume. 4 times 4 is 16, 24, 25, 32, 34. Bring my 0 down. 2 times 4 is 8. 2 times 6 is 12. 2 times 8 is 16, plus 1 is 17. After you add this together, 4 plus 2 is 6, plus 1 is 7. 10, 2. Okay, so my answer is 20,736. How do I label it? I label it inches cubed. Or again, you could also label it cubic inches. Okay, and that is the second part of example 4. Now I'm going to go over example 5 tomorrow with you in class, so you won't have to write that one down. And looks like we have another example, example 6, that we'll cover tomorrow as well. Okay, example or practice problems. We have, let's do practice problem B for example 5. Practice problem B says, find the volume of this rectangular solid. It's a cube. Okay, it's a cube, so each side is the exact same, and it says that each side is 3 centimeters. So the length, the width, and the depth are all 3 centimeters. It said find the volume of this three-dimensional object, so we need to multiply length times width times depth. 3 times 3 times 3. Okay, I know that 3 times 3 is 9. 9 times 3 is 27. How do I label this? I label it centimeters cubed. Alright, and that is all for today. I hope you have a great night, and I hope this wasn't too confusing. Pretty difficult concept, a new concept for you especially. This is not building on anything you learned in the 4th grade, so this is going to be tricky for us. Just keep working at it and keep trying your best, and I know that you will understand it eventually. Thank you very much. Have a good night.